Good afternoon, all. This is your ninth lecture of solid mechanics, and we are going to study the chapter SFD and BMD. Okay. We have 4 chapters in your final semester exam, and this is the second chapter, chapter number 2. My name is Sachin Tolkar, you know. We are going to see the introduction to SFD BMD with applications. So, objective of this lecture is at the end of this lecture, we all should be able to understand shear force and bending moment diagram for transverse loading. Normally, for mechanical engineering, in second year, we are going to study only transverse loading. The axial loading will be in final year. The second objective of this lecture is relation amongst loading, shear force, and bending moment. You might have occurred with questions related with if the loading is so and so, how will be the shear force and how will be the bending moment diagram. So all these things we are going to cover here, and actual relation of mathematical relation we are going to study in this lecture. So firstly, what types of beams are there, or what is meaning of the beam? A structural element subject to the transverse load to axis is known as a beam. Beam is either free from axial load or its effect is negligible. In case of civil engineering, the axial loading is negligible. In case of mechanical engineering, what happens if we are considering shaft as a beam, then for helical and bevel gearing, we get the axial loading also. But right now, for timing in second year, we are going to neglect the axial loading. Now, types of support. These are example of roller supports. We denote it by these symbols. The symbol like this. This is a roller, a triangle, and rollers are shown. Or a simple a ball bearing type of thing is shown. Or if the support is rolling here, sliding here, or with the help of arrow, we can show the roller support. So then hinge support is there. In hinge support, horizontal as well as vertical reaction will be there. Hinge joint is shown like a circular ball and 2 lines on both sides. In case of fixed supports, we get reaction as well as moment, bending moment at that particular point. So that we have to remember. In case of roller support, there is only vertical loading. Now types of beams. Simply supported beam, if there is one hinge support or roller support is there, or both roller supports are there, then we call it as a simply supported beam. A cantilever beam where there is one end is fixed. A fixed or built-in beam which having both the sides or both the ends fixed. Propped cantilever. Propped cantilever is nothing but you'll get loading, and this particular cantilever with we can say propped cantilever. The diagram is wrong. In propped cantilever, the support is in between and this loading is outside the cantilever. So that is called as propped cantilever. And this is called as continuous beam, in which there are multiple supports and multiple loading is there. Then it is called as a continuous beam. Now, what is meaning of shear force and bending moment? We are going to see with the help of this example. If suppose this loading, this beam is given, the beam as shown in diagram is given, and if we'll consider there is a loading of 5 kilonewton, 10 kilonewton, and 8 kilonewton at different places, and the reactions are there. We have calculated that reactions, and if you want to calculate shear force at this section XX, this section XX, if I want to calculate the reaction at this particular position, then what I'm going to do, I'm going to cut this beam into two pieces at section, and it will be separated as shown in the next diagram. I'll show it. So this is for simplification. I'm going to simplify it with cutting that section, and I'm going to calculate shear force on the left side or right side of the beam, and you will be surprised that the shear force on both the sides and bending moment on the both sides are exactly same and opposite in direction. So suppose I'm going to calculate in leftward direction, what will happen? 8.2 kilonewton in upward direction minus 5 kilonewton in downward direction. It will be 3.2 kilonewton in upward direction. Bending moment 8.2 into 6 minus 5 into 2. We are going to see the sign conventions in next slide. So it is 39.2 kilonewton meter clockwise. Now if I'll see from right side what will happen, 14.8 kilonewton here in upward direction, 14.8 kilonewton in upward direction, 8 kilonewton in downward direction, and 10 kilonewton in downward direction. It is minus 3.2 kilonewton, which is 3.2 kilonewton in downward direction. You'll see the shear force from left side and shear force on the right side are exactly same and opposite in sign convention. It is upward, here it is downward. Moment experienced. Again, I'm going to calculate this moment from this point, 14.8 into 9 minus 14.8 into 9 because it is anti-clockwise. 8 into 8, this 8 kilonewton into 8 plus 10 kilonewton into 3 minus 39.4 kilonewton, that is anti-clockwise 39.2 kilonewton meter. So it is exactly same and opposite in direction. So while calculating shear force and bending moment diagram, you can take a left side or a right side approach and your answers will be same. Now this is the answer which we have calculated here, has been shown here. So the definition of shear force: the algebraic sum of the vertical forces acting on the beam either to the left or right of the section is known as shear force at the section. So we are going to calculate shear force from left or right direction. One minute. So, and bending moment, the algebraic sum of the moments of all forces acting on the beam either to the left or right of the section is known as bending moment at the section. So these are the definitions of shear force and bending moment at any section. We are going to see this 3.2 kilonewtons in upward direction, and it is equally balanced by 3.2 kilonewton in downward direction. Similarly, 39.2 kilonewton here clockwise and 39.2 kilonewton anti-clockwise. This is the bending moment at that particular section. Now, what is the difference between moment and bending moment? We know for calculating bending moment, we are going to use moments, but moment and bending moment both are different concepts. Now, moment is, it is a product of force and perpendicular distance between line of action of the force at the point about which moment is required to be calculated. So moment is simply product of force and perpendicular distance. So we are going to calculate moment at that particular point with the help of force and perpendicular distance. But bending moment is the moment which causes bending effect. We know moment at any point on the equilibrium beam will be zero, but there will be bending moment at that particular point which causes bending effect. And that's why the moment which causes bending effect on the beam is called as bending moment, and it is generally denoted by M or BM. We are going to use M or BM, both the sign conventions for the calculations. Now sign conventions. This is called as left upward positive, L U P. Left upward positive, right downward, obviously it is negative. Here left downward negative, LUP and LDN, that we are going to remember for this particular subject, strength of material or solid mechanics. So LUP and LDN will be your final sign conventions for calculating shear force. Now for bending moment, we know this smiley face is a sagging bending moment. So we are going to consider this smiley face as a sagging or positive bending moment. Obviously, this hogging bending moment, this is a crying face, we can say crying lips, and we are going to consider it as a negative bending moment. Always remember, sagging is positive and hogging is negative. That sign conventions you are going to follow in this particular subject. Now these are the definitions of SFD and BMD. The diagram which shows the variation of shear force along the length of beam is SFD, and along this variation of bending moment along the length is called as a BMD or bending moment diagram. These are the simple definitions. No need to remember, no need to mug up also. Now what is point of contraflexure? It is the point on the bending moment diagram where bending moment changes the sign from positive to negative. It is also called as inflection point because bending moment at that point is zero. So it may be like this. If the bending moment diagram is changing from positive to negative, this particular point will be called as point of contraflexure. This particular point we have to calculate in your calculations in bending moment diagram. Now the relation between load, shear force and bending moment. So there is a small derivation type of thing. We don't need to do derivation in the exam, but we should know how the shear force, bending moment and loading are interrelated with each other. That's why this has been derived. So this is a shear force, V, that symbol is given for shear force, vertical force, and it is a derivative of bending moment with respect to the length of that particular beam. So derivative or differentiation of M with respect to X is called as shear force. And that's why we know that if we calculate derivative is nothing but slope of the line. So if I know the bending moment of any particular object, I can calculate the shear force of that object with the help of derivative. So derivation, this is the relation between shear force and bending moment that we have to remember. Similarly, if I'll take derivative of shear force, I'll get loading. So derivative of shear force with respect to distance, we'll get the loading of that particular diagram. intensity of load and shear force that just now I have explained you. That is, if I'll take the derivative of shear force, I'll get the loading derivative with respect to length. These two relations we have to remember forever for your lifetime. Now, these maybe this table is very important because lots of questions have been asked in your online exam on this variation of shear force and bending moment. So, shear force diagram between point loads or no load region, shear force diagram is horizontal. If the loading is UDL, uniformly distributed load, SFD will be inclined line. And if the loading is uniformly varying load is nothing but it is a parabolic loading condition. This type of loading condition is there. So in case of parabolic loading condition, what we will get 2-degree curve or parabolic curve in shear force diagram and a cubic parabola in bending moment diagram. Here, if there is no loading, then horizontal line in case of shear force diagram and inclined line in case of bending moment diagram. Uniformly distributed load, inclined load line in shear force diagram and 2-degree parabola in bending moment diagram. Here a uniformly varying load, it will be 2-degree curve and 3-degree curve. Pawan, don't do drawing here. Okay. Now you can unmute yourself if you want to ask any questions, queries related to this. We are going to take around 10 to 15 lectures in this 15 days to cover all unit number 2, 3, and 4. All units we are going to cover till 4th of May. So if there is any question, you can unmute yourself and ask the questions because right now due to COVID situation, you all know that we cannot meet face to face, but we can have conversation here. Anyone? Okay, around 1, 2, 3, 4, 7, 8, 9. 9 students are there. Okay, if there is no question at all from your side, then I'll think that you have understood all the things whichever has been delivered in this lecture. So I'm Sachin Todkar signing out till we meet again in next lecture. Maybe tomorrow itself we are going to meet. And till then, goodbye. Recording. Stop.